Hello and welcome back to our channel. I'm Steve Cross, Mechanical and Technical Engineer, and today I'm here with Jonathan Gulliver, who is our specialist in pumps. We're going to be talking about selecting electric motor and control system for pump applications. Thank you for joining us, Jonathan.
Hi, excited to be here today.
So, Jonathan, when selecting the right motor and control system for a pump application, what are the typical challenges we face?
Well, one of the first things we need to consider is the electrical supply available. This could be single-phase, three-phase or DC, and it really depends on whether the application is commercial or industrial. These days we often see DC in machines that require 12, 24 or 48 volts, especially in transport applications, and sometimes we see even higher voltages.
Interesting. Okay, so what other factors come into play during this process?
Another critical factor is local environment. For instance, we need to consider ingress protection. That's protection from exposure to water, dust and dirt. Some motors are fully enclosed and protected, while others might be placed within machines where the machine itself provides protection. For applications that need high protection, we might use motors with IP69K rating, which means they're resistant to high pressure water jets. Some motors even need to be submersible.
Okay, so it sounds like there's a range of complexity in pump applications. Could you give us an example of a simple control setup?
Sure, a good example is filling a car with petrol. When you hold the nozzle fully open, the pump runs at full speed, moving fuel to the car. When the flow slows, the pump begins recirculating fuel through a bypass valve while still running at full speed. It's a traditional setup and it works, but it's inefficient, since fuel is moving in a loop without filling the tank faster.
Okay, that's fascinating. And now let's talk about speed, power and torque requirements. What considerations are important here?
We look at what's called the duty point, the specific operational point for the pump in terms of head and flow rate. For OEM applications, this can be precisely defined. However, in an open market, the requirements may be broader. Different operating conditions cause the pump to draw varying amounts of power. For example, a small centrifugal pump draws more power when the valve is open than when it's closed, which can be tricky in certain applications.
Okay, and how does temperature impact the decision-making process here?
Temperature is crucial. Motors have maximum operating temperatures, and exceeding these can cause overheating. Each motor has a specific temperature range, and if it gets too hot, thermal cutouts can automatically stop it. But ideally, we do not want to rely on these cutouts. Instead, we designed the application to operate within safe temperature limits to ensure efficiency and longevity.
Okay, so what are some ways to maintain the unit's temperature within these operating limits?
A common method is to use a fan on the back of the motor shaft to help dissipate heat. However, in certain IP-related rated environments, fans might not be allowed. In many pump systems, the fluid itself helps cool the motor, which is an added advantage.
Okay, that makes sense. Can you give us some more insight into a few types of motors and their application?
Certainly, basic motors like fixed-speed AC motors are simple, rugged and reliable, often used for straightforward applications. Their speed can be adjusted with an inverter if needed. Then we have brush motors, which are also reliable, though their lifespan depends on brush wear. Moving on to more sophisticated setups, we use brushless DC motors with advanced control systems for applications requiring more precision.
And what about metering pumps? How are those controlled?
Metering pumps such as peristaltic or piston pumps are used for precise fluid displacement. They require accurate control, so we typically use stepper motors or motors with high quality encoder feedback. These motors work closely with flow meters or other sensors to ensure precise measurements in every cycle.
Okay, and finally, Jonathan, what are some of the common trends in the pump industry when selecting motors?
The main trend is an increased demand for motor control. For example, there is a growing need to maintain tight temperature ranges in electronic control systems, which an on-off motor cannot manage effectively. We're seeing more demand for variable speed drives, which allow for finer control. These systems often use PWM, pulse width modulation signals, for precise speed adjustments and may interface with protocols like CAN or EtherCAT.
Okay, thank you, Jonathan, for that overview, and thank you for watching. If you are interested in learning more, then use the contact information on screen or in the description.
Thanks, it was a pleasure to share some insights into the world of pump applications and motor selection.
Thanks everyone for watching. Don't forget to like, subscribe and leave your questions in the comments. Also check out the end cards for more videos. See you soon.